All right, section 9.2, the real number system. All right, and this is actually a section that just adds on to one of the chapters or one of the sections we learned early on in pre-algebra, where we talked about natural numbers, whole numbers, integers, and we introduced rational or fractional numbers. And if you remember, we did the properties of integers with adding and subtracting, all that. So we're just adding onto that number system, but we'll review what we had previously covered. So our learning targets for today is to identify and compare numbers in the real number system. And that's all we'll do today. But the second part, we're going to learn how to solve equations finding square roots. So essentially building on what we did in section 9.1, where we introduced the concept of square roots. So key terms today, right? We have rational numbers that can be written as fractions, right? And we talked about how rational numbers can be written as fractions, and you can identify the decimals because they're either repeating, such as, right, like 1/3, right? As a decimal in my calculator, that's 0.3333, right? So that's a repeating decimal. That's rational. A irrational number is one that does not end and does not repeat, right? So if you remember, if you typed in pi, right, it's a 3.14159 dot dot dot, no pattern, keeps going on. That is irrational. Okay, there's no way to write it as a fraction. And then the real numbers, it's the set of all rational and irrational numbers, and we'll look at that building block and what it looks like here. So remember the real number system, right? We start with natural numbers or the counting numbers. So 1, 2, 3, 4, 5, 6, right, and so on. Those are natural numbers. And then we add 0, and that's the number set called whole numbers. Okay, so we add the 0 in there, right? So 0, 1, 2, 3, 4, and so on. And then we had integers, right, where we have all those whole numbers, plus we add their opposites, right? We add the negative side to that. So it's all the whole numbers and their negatives. And then we had rationals, okay? So it's all the integers and then the fractions in between. So 1/2, 3/4, -5/7, right, and so on. So those are adding the fractions in there. All of these here are rational numbers. Okay, and then we're going to introduce the concept of irrational. So if it's not rational, it's irrational, meaning that it's non-ending, non-repeating decimal. There's no overlap between rational and irrational. You can't be both of these, right? Some numbers, right? Pi, right? And you're like, why are we learning about this now? It's because the square root of 2 is irrational, okay? A lot of the square root values we find are going to be irrational. However, for example, square root of 25 is going to be considered rational because the square root of 25 is 5, right? Which puts it as a natural number, a whole number, it's an integer, and it's rational. So it falls in all of those. So you can't just say all square roots are irrational. That's not true. All right. The perfect squares, especially, are not. And then real numbers, right? All of these sets are considered real numbers. Okay. They're not made up, they're not make believe. You might be saying, okay, well, what is not a real number? And I'll kind of relate it to what we talked about in 9.1. The square root of -9 is not a real number. Okay. The solution to that would be imaginary. And that's something you'll learn in as classes you go up, so you don't have to understand that at all. But remember, we talked about the reason is a root is something, a square root is something times itself equals this value. And there's no way to get a negative when you times something by itself, because we said positive times a positive is a positive, and a negative times a negative is a positive. So when I have that root with the negative under there, it's not real. There's no real solution to that, right? It's an imaginary thing. So that would be an example of a number that's not real. Okay, we're not studying those. we're looking at these number sets. So let's look at the real number system. So you can see here, everything is a real number, right? It starts with my counting numbers, right? 1, 2, 3. So if it's a natural number, it's also a whole number, it's also an integer, it's also rational, it's also real. The only set it's not involved is irrational. Okay. Now 0 starts up the whole number. So 0 would be whole, integer, rational, and real. Right? Once I add a negative in there, so -5, okay, that's an integer, it's also rational, it's also real. So it goes this way down the line, right? Meaning -3 is not a whole number, -3 is not a natural number, it goes this way. It's an integer, rational, and real. Right? And then the rational numbers, a fraction, 1/2, that's rational and it's also a real number. Okay? It is not an integer. It's not a whole number. It's not a natural number. It does not go this way. Okay. And then it's either rational or it's irrational. All right. So if I have pi, this is another number on your calculator, E. It's weird to call that letter a number, but it is a number. And then just like pi is, right, 3.14. And then square root of 2 is another example. These aren't the only ones. Those are just examples of irrational. And remember, we can tell if it's a decimal, for example, 0.2514372 dot, 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 right? There's no repeat and there's no end to it. That is also irrational. And all irrational numbers are also real. So let's look at some examples where we're classifying, right? And we're going to see what sets they belong to. So if you remember, 0 was first introduced as a whole number, okay? It's not natural because I'm not counting with it. I don't start at 0 when I count. I start at 1, 2, right? So it starts as a whole number, and then it's going to be integer, rational, and real. Remember, it can't be both of these. 2, that's a counting number. It's also whole, right? There's no parts to it. It is an integer, it's rational, and it's real. -7, where was that first introduced, right? If you remember, that's introduced as an integer, right? So that means it's rational and it's also real. 3/4 fractions, okay? It's not natural. Don't count with it. Doesn't right? The 0 in the natural, nope. Nope. It's a rational here and real. Square root of 2, right? And you might say, well, I don't know. You said all square roots are not. But if I type in square root of 2, right? Look at this 4, 1, 4, 2, 1, 3, and it doesn't stop and it keeps going on. That is irrational, right? It's also real. Square root of 25, right? If I type, we should recognize that. Square root of 25, 5, right? It's a natural number. It's a whole number, right? It's natural because I count with it, whole number, right? And once I start there, I keep going. Can't be irrational because we checked off the rational box. Here, decimal, you might see, oh man, that keeps going on forever. But look at it, it's 1, 2, 1, 2, 1, 2, 1, 2. That is a rational number because it repeats and it's real. Here, 0.124343, nope, no pattern. It goes 5, 4, right? So that is an irrational number and it's real. So I know those number sets are a little bit confusing. So here's what I want you to do. I want you to start with just a short practice assignment, just listing what sets does a number belong to. So page 444, doing 13 to 25 and 69 and 70. Let me know if you have any questions. Look forward to talking to you soon.